All right, we're going to do some Unit 7 review, which is systems of equations. So first we need to remind ourselves that a system of equations is just a set of two equations. So you'll have two equations, and on your graph you'll have two lines. So a system, an example would be something like y equals 2x minus 4, and y equals 1 over 3x plus 1. Two equations, and then when you were to graph them, you would have two lines. That makes a system. So how to tell if some point is a solution to the system? Okay, so we'll start with first, I'll give you a coordinate point of, let's say I have 3, 7. And then I have the equation y equals 2x plus 1, and I have 2x plus y equals 10. To tell if it's a solution to the system, you just need to take your x value and your y value and plug them in for x and for y into both equations. Okay, and then you'll just test and see if it works or not. So if we run through that real quick. So using the first equation, my y value is 7. So I'm going to see if 7 is equal to 2 times my x value is 3 plus 1. Well, there's nothing to do here on the left side. That's just 7. Then on the right side, you can either type that into your calculator or do it in your head. 2 times 3 plus 1. 2 times 3 is 6 plus 1 is 7. Then does 7 equal 7? Yes. So that solution, or that point, is a solution to the first equation. But now we need to test the second equation. Okay, it has to work for both of them to be a solution to the system. So now I'm going to do 2 times my x value is 3 plus my y value is 7, and I'm going to see if that equals 10. Okay, same thing here. We can use a calculator, use your head. On the left side, we have some things to do. 2 times 3 plus 7. 2 times 3 is 6 plus 7 is 13 equals 10. Does 13 equal 10? No, it does not. So is the coordinate point 3, 7 a solution to the system? No, because it did not work for both. It has to work for both to be a solution to the system. Okay, now let's talk about for the graph. If you have a graph, first of all, let me draw a quick little graph in here. I've got my x, y axis. You're going to have these two lines. The graph is very, very easy to tell your solution. You're just looking at their intersection. Whatever that coordinate point is your solution. Maybe that is at 3, 4. That's how you can use the graph to find your solution. Oh, not meaning to move that, sorry. The last part we need to talk about is how many solutions they have. So it is possible to have one solution, no solution, or infinite. So let's talk about the equations first. Using the equations, you can have one solution if you solve and get values for your variables. So you get like x equals 2 and y equals 5 when you solve. That means that's your solution. You get no solution if you get something like 3 equals 7 when you solve. Because 3 does not equal 7, so that means no solution. You get infinite if you solve and get something like 5 equals 5. That's infinite because 5 does equal 5. In both of these cases, no and infinite, you have no variables left. No variables left. as opposed to one solution, you should have variables left and have answers. Using the graph, which is what you're going to focus mostly on, one solution is your graph intersects, just like we saw back up at that example right above. Right here, this is one solution. They intersect. No solution means they're parallel. You might have lines like this. They never touch. That is no solution. And then the last one, infinite. Infinite means that every single answer for one line works for the other line. You have infinite solutions if you just have one line, or if your lines are the same. So an example of that, let's say you graph your first line and you get this equation, graphs makes that line. And then when you graph the second one, it is right over top of it. It's the exact same line. That is infinite. Okay. At this point, I'm going to show you a couple of examples on the IXL to just show you how to take care of this, because there's a couple of tricky things with it. So like I said, you're going to focus mostly on the graphing part. So this is I believe the second IXL you're supposed to do, AA.2, okay? So you're going to solve the system by graphing. So what you need to do first is you need to graph both of these, and then you can say what the solution is down here. So you notice these two different colored, they're buttons. You are going to click on the first one to graph the first equation. So your y-intercept is -6, and your slope is -4, which means down 4 and right 1. That is a negative line. Remember, that is over 1. Then after that line is graphed, you're going to click on the second button and graph that one the same way. Your y-intercept is 3, so go up to 3. And then your slope in this case is 5, or 5 over 1, and it's positive, so up 5 and over 1. Now your lines should cross at a nice intersection, and if they don't, you should go and find where your mistake is. Look to see if your y-intercept, your slope is wrong on one or both of them. Definitely check your direction of your slopes. The purple graph is negative, so it should be a negative direction. The green graph is positive, so it should be a positive direction. Then once you have your two, you look at their intersection. It is -1, -2. I'll go through a couple more in case you want to see a couple of other examples, but this is essentially all you're doing on these IXLs. So click on the first button. Your y-intercept is +4. Your slope is -4. So your y-intercept is +4, go up to 4. Your slope is -4, which means go down 4 and right 1. Second equation, your y-intercept is +3. Your slope is -3. So +3 for your y-intercept. And then -3 for your slope means down 3 and right 1. See where they cross? That's your solution. They cross right here. That point is 1, 0. Same thing. Our first graph has a slope of -8 and a y-intercept of 2. So y-intercept is 2. Slope is -8, which means you need to go down 8 and over 1. Your next one, you don't have an x, which remember y equals equations go side to side. So y equals -6, go to y equals -6. There's your line. Find your solution. It's at 1, -6. At this point, you should hopefully be able to continue on. I want to point out this is a great example to leave off on. Remember that there's an imaginary 1 on this, an imaginary -1 on the second one.